Right, children. Now, in the previous chapters, we learned that the importance of electricity in our day-to-day lives, and also we learned some methods of generating electricity. Under that one, do you remember we learned that by moving a magnet inside a coil of wire, we can generate electricity, and we further learned that this method of generating electricity by moving a magnet near a coil of wire or inside a coil of wire is used in dynamos and generators and also in small motors. Okay, children? So in this chapter also we are going to learn further about some methods of generating electricity, right? So this activity, let's make a small hydropower station. What do we need to do this activity, children? We need a small motor and a bulb, we need a galvanometer, we need a cork, some yogurt spoons and an empty pen tube. We'll write them down. Small motor, bulb, we need a small bulb, galvanometer, we need a cork, some yogurt spoons, instead of the yogurt spoons, we can use some small metal pieces as well, small metal sheets, because we need the yogurt spoons to make a turbine, right? To make a model turbine. So we need to insert these yogurt spoons to this cork, and that's how we are going to make a model turbine. At the same way, instead of the yogurt spoons, we can insert small metal sheets to this cork and we can make a model turbine. Therefore, instead of yogurt spoons, we can use small metal sheets as well, okay? Right. And an empty pen tube. Right. Small motor, bulb, galvanometer, a cork, some yogurt spoons, and an empty pen tube. These are the things we need. How to do the activity, we'll see. Look at the method. You have to make the setup like this. We'll label this first. Motor, galvanometer, yogurt spoons, cork. Small motor, galvanometer, yogurt spoons, and cork. Okay, children? Right. We'll go through the method. Prepare the setup as shown in the figure, right? You have to make small slits with a blade in the cork and you have to insert the yogurt spoons. As I told you all before, instead of the yogurt spoons, you can use small metal sheets as well. So this is similar to the turbine. Okay, children? And then this is a small motor. Here you have to insert the empty pen tube here. You have to label that as well. Pen tube. Okay. So when you look at the motor has a small axis. You have to insert the pen tube to that axis and the other end of the pen tube should be inserted to the cork. And using connective wires, the two terminals of the small motor should be connected to the two terminals of the galvanometer. Okay, children? Right. Prepare the setup as shown in the figure. Open the tap and hold the turbine to the running water. This is the turbine. This is a model turbine. You have to hold this turbine under running water. It will start to rotate. Okay? So, do not wet the motor. And fix the galvanometer and the bulb to the terminals of the motor. So first of all, we can connect it to the galvanometer, then we can connect it to the bulb. Even using galvanometer itself is enough. Okay, children? So record the observations. So when we hold this small like model turbine under running water, you will realize when this will start to rotate, and when it rotates, this galvanometer indicator moves or deflects. Okay, children? Right. Then fix a wind vane instead of the turbine and hold it to the wind. Right? So you can use the same setup. Instead of making a different wind vane, what I am going to do in the lab is I am going to hold this under flow of air. Right? I am going to use a drinking straw to blow air onto this turbine, and you will realize when the flow of air comes here, right? It will start to rotate, and then again indicator will move, right? So then fix a wind vane instead of the turbine and hold it to the wind and record your observations. We are going to do this activity now. Right, children. Now we are going to make a small hydropower station. Now you all know using hydropower stations we can generate electricity. Right, children? So look at this setup, children. Can you all see? I have made a small turbine using these pieces of metal and cork stopper. Observe carefully. And I have connected this small turbine to a small motor. Can you see the small motor, children? Right. So the two terminals of the small motor is, now you can see the red wire from this side and the black wire from the other side. So the two wires are connected to the terminals of the motor, and the other ends of the two wires are connected to this galvanometer. Now you all know that the galvanometer is used to measure small electric currents, right? So look at the indicator of the galvanometer, children. It is at 0, which means at the moment electricity does not flow through the galvanometer. Now what I am going to do is, I am going to show you all how electricity is generated in hydropower plants. So for that one, I am going to pour this water onto this turbine. So the turbine will start to rotate. So when it starts to rotate, you all have to look at the indicator of the galvanometer and check what happens to the indicator. Okay? Right. Observe very carefully. Right. What happens, children? When I pour water over this turbine, the small turbine, it starts to rotate. When it rotates, this indicator starts to move, which means when we rotate this turbine, electricity is generated in this setup, in this circuit, and it makes the indicator of the galvanometer moves or deflects, right? So at the moment, this turbine is not rotating, therefore the indicator is at 0. Look, when I rotate it, what happens, children? This indicator moves. So when I rotate this one, electricity is generated, making this indicator moves, right? So in the same way, electricity is generated in hydropower plants. So there what happens, there's a large turbine. This is equal to that, this is similar to that turbine. And that turbine is connected to a dynamo. Now this small motor is equal to that dynamo. Okay. So then what happens, children? Because of the flow of water, that turbine rotates, and when the turbine rotates, the dynamo can generate electricity. Right, children? In the same way, when this turbine rotates, the small motor generates electricity, and that electricity flows through the galvanometer, and thereby the indicator moves. So this is how hydropower plants generate electricity. So what happens in the wind power plants, children? Instead of the flow of water, wind is used to rotate this turbine. So in order to show you that one, so now here inside the lab I don't have wind. So instead of the wind, I am going to blow air using this straw, right? So then what happens? You have to observe. while you are observing this one, look at the indicator of the galvanometer as well. Okay, children? What happens, children? When I blow air onto this turbine, it rotates, and when this turbine rotates again, this indicator moves. A similar process takes place in wind power plants. Because of the speed of the wind, the turbine rotates, and when the turbine rotates, as it is connected to a dynamo, it can generate electricity. Right, children. So you observed what happened. So what did I do again? I made the setup like this, and I held this small turbine to the water, to the running water. Then what happened? It rotated, and then a galvanometer indicator moves. That first activity was similar to the same activity takes place in hydropower plants. Okay, so in hydropower plants, turbine is present. The turbine can be rotated because of a flow of water. Right, flow of water at high speed, that water flows at high speed, and when it falls onto this turbine, what happens? The turbine rotates. So when the turbine rotates, as the axis is connected to a generator, the generator can generate electricity. Right? So this small motor is similar to the generator or the large dynamos present in the power plants. Right, children? Now you all know when we consider these large generators and dynamos, and even in small motors, everywhere the same theory is applied. There, even though we can't see inside, a small magnet is present, like in a small motor, small magnet is present, but when we consider the generators and large dynamos, a very powerful magnet is present. Right? So the axis of the generator, or here in case this motor or the dynamo, is connected to the turbine. So when the turbine is rotated, what happens, children? Along with the axis, now axis from inside is connected to the large magnet. So the magnet also rotates, and next to the magnet a coil of wire is present. So when the magnet rotates, you all know now the coil of wire can generate electricity. Right? So this setup, the first instance, this is similar to the hydropower plant. Okay, hydropower plant. So this part is similar to the turbine. This part is similar to the dynamo part. This acts as a dynamo in the hydropower plant. Right, children? In the second instance, what we did, children? What we did was, using the same setup, instead of using flowing water, we used the air blown to this setup, this turbine, to rotate the turbine. Do you remember I used a drinking straw to blow air onto the turbine? So that blown air is similar to wind. Right? So because of blown air, what happens? This one rotates, and when this one rotates, the small magnet present inside the motor rotates and electricity is generated. Right? That is why the galvanometer indicator moves. So the only instance the galvanometer indicator moves is only when electricity flows through it. So in both the instances, using water and using air, right? That air is similar to wind, right? We can generate electricity. Both the instances, galvanometer indicator moves, which means electricity is generated. So in the second instance, this small turbine is equal to the wind vane, right? And this is similar to the dynamo in the wind power plants. Right, children? We will write the observations first. When the turbine was held, the turbine was held to the water, and then to the wind. Real wind was not there, but using tube we blew air. Right? When the turbine was held to the water and then to the wind, the turbine rotates and the indicator of the galvanometer deflects. Okay. When the turbine was held to the water and then to the wind or air, the turbine rotates. These are the observations. The turbine rotates and the indicator of the galvanometer deflects. Indicator of the galvanometer deflects. These are our observations. So what is the conclusion? So we all know now, in order to deflect the galvanometer, right, in order to move the galvanometer, electricity or electric current should flow through the galvanometer. So that is possible when that small motor generates electricity because of the rotation of the turbine. Okay, children, we'll write. The galvanometer indicator deflects due to the flow of electricity. Therefore, electric current is generated by the motor. This happens due to the rotation of the model turbine. Right. Due to the rotation of the turbine. And at the same time, we all know the small motor acts as a dynamo. Small motor acts as a dynamo. Okay. The galvanometer indicator deflects due to the flow of electricity. Therefore, an electric current is generated by the motor due to the rotation of the turbine, right? The small motor acts as a dynamo. So it's very clear this is a similar activity takes place in power plants, right? In power plants, there's a huge dynamo, a large dynamo. The dynamo magnet can be rotated because the axis of it is connected to the turbine, and because of different ways, right? By different means, we can rotate the dynamo and electricity can be generated. We'll move to the next part. So now we are going to learn about power stations in Sri Lanka. There are different types of power stations in Sri Lanka. So now we all know that in power stations, a dynamo, a large dynamo, a generator is there. So to make this generator work, we have to connect it to a turbine. So because of different methods, we use to rotate the turbine. So now only when the turbine is rotated, as the turbine is connected to the generator, it can generate electricity, right? So there are different ways of rotating this turbine. So because of the different methods of that we use to rotate the turbine, we have different types of power plants. We are going to learn about them here, right? Different types of power stations and methods they use to generate electricity in Sri Lanka is given here in this table. We have to fill this up, type of power station, right? So look at this one, method of production. Fix a dynamo to a large turbine and rotate the turbine with the help of a stream of water. Right? How do we do that? So fix a dynamo to a large turbine and rotate the turbine with the help of a stream of water. Here, what type of power stations are these? Hydropower stations. Let's try this first. Hydropower stations. Hydropower station. Right? There what happens? There's a large turbine. Right? That axis is connected to the generator. So inside the generator, you all know there's a large magnet, a powerful magnet. This axis is connected to that magnet. Right? So a coil of wire is next to this one. So when this one rotates, what happens? When the turbine rotates, this magnet also rotates, and because of the movement of the magnet, coil of wire generates electricity. Right? Okay. That's how it happens. So there are different methods we can use to rotate this turbine. Right? So when it comes to hydropower stations, what happens, children? Using a flow of water, we can rotate this large turbine. Right, children? Fix a dynamo to a large turbine and rotate the turbine with the help of a stream of water. So we have already explained this in the 4th lesson as well. Do you remember this, children? Under hydropower, we explained that water is stored at a higher elevation, higher location, and because of that, certain energy is stored in the water, and that energy is known as potential energy. Right? So when water's, now here, if this is the reservoir, at a higher elevation, water is stored. Right? And that water flows through the canals, it flows towards this setup, this turbine, and then what happens? Potential energy converts to kinetic energy, the moving energy. And because of the high speed of water, this turbine also rotates at high speed. If the speed of rotation of the turbine is very high, more amount of electricity can be generated. Right, children? So this is the process takes place in the hydropower plants. Look at this one, the locations. Kotmale, Lakshapana, there are several power plants. Victoria, Rantambe, Randenigala, these are some examples. There are many other power plants in Sri Lanka, hydropower plants. Right? Umaoya project is there, and Samanulavawa power plant is there. Udawalawa power plant is there. Right, children? Only some examples are given here. Okay, children? Right. Look at this one, the second one. Rotate a dynamo with the help of a wind vane. So instead of this turbine, water turbine, we can connect a wind vane. Okay, children? So this wind vane, how can we rotate the wind vane? Using a flow of wind. Okay, children? Rotate a dynamo with the help of a wind vane. What type of power plants are there? These are the wind power plants, wind power stations. Wind power station. Right? So in wind power station, what happens? A wind vane, a large wind vane is there like this. These type of blades are there. Because of the wind, they rotate. So it is connected to a generator. So generator has the magnet, and when it rotates, electricity is generated inside the coil of wire. Right, children? So these type of wind vanes, so these type of wind power plants are present in an areas with strong currents of winds. Right? So wind power station, rotate a dynamo with the help of a wind vane. Examples, these are the main examples. Hambantota, Puttalam. Instead of these things in Ambevela and even in Mana and some other mini power plants, wind power stations also they are in different areas. But basically wind power stations are located at Hambantota and Puttalam areas. Right? But in Mana and Ambevela areas also wind power plants can be seen. Okay, children. The next one. Fix a dynamo to a turbine and rotate the turbine with the help of steam. What is this, children? This actually happens in coal power plants or thermal power plants. These are known as coal power plants or thermal power plants, right? So, we'll write this first. Coal power station. Right? So, how do we do this, children? So, I told you, each instance we have to rotate the turbine. Based on the method we use to rotate the turbine, we give different names to these power plants. Okay, children? Right. So, how do we do that? The same setup is here. Now, here in the hydropower plants, you all know that we use a flow of water to rotate the turbine. Right? In wind power plants, we use wind to rotate the wind vane or the turbine. Right? Okay. So, what happens in coal power stations or thermal power stations? We rotate the turbine using a powerful amount of steam. Right? Powerful flow of steam. Fix a dynamo to a turbine, the same method. Rotate the turbine with the help of steam. Remember, just normal steam cannot be used to rotate this turbine because I told you, remember, in order to generate a large amount of electricity at once, we have to rotate the turbine fast, right, at high speed. So, in that case, normal steam is not enough. So, in this case, we have to produce steam at high pressure, right? How to produce steam at high pressure? This is done by burning coal, and this coal is used to heat water in large boilers, right? So, by burning coal, coal is a fuel, a fossil fuel, you can obtain a large amount of energy at once. This heat energy is used to heat water, large amount of water inside the boilers, right? So, when large amount of water is boiled at once with large amount of heat, steam at high pressure is produced, right? The steam at high pressure is sent through this turbine, and because of the pressure of the steam, this turbine rotates, and then thereby the generator can generate electricity, or the dynamo can generate electricity. Right, children? So that is how using steam, right? But the steam at high pressure, we'll write steam at high pressure. Okay, children? So is used to make this turbine rotate and thereby to generate electricity. So basically, the largest thermal power plant is located in Sri Lanka in Norachole. It is known as Lakvijaya Power Plant. Okay, Lakvijaya Power Plant is the largest power plant. We'll move to the next one. Rotate a dynamo with an engine. Here, this method is used in fuel power stations. Fuel power stations. Right, or fuel power plants. So, rotate a dynamo with an engine. Using an engine, the dynamo is rotated. Instead of this turbine, using an engine, the dynamo is rotated. And to make the engine work, we have to use fuel. Basically, most of the time we use diesel, right? So, using diesel, by burning diesel, we can make the engine work. Engine can rotate the turbine. Okay, children? So, these type of power plants we can see basically in Kalanitissa, Sapugaskanda, Kerawalapitiya, like areas. Okay, children? So, it's very clear now. These are the main methods of generating electricity in Sri Lanka, right? So, different names are given because of the method of generation of electricity is different. Right, children? Okay, we'll move on to the next. Right. So look at these pictures, children. Structure of a hydropower station. So even though we discussed about a turbine and dynamo, we can't see any of them clearly because they are all covered here, right? But inside, you can, inside these covers, the turbine is also present, okay? Right. A wind power plant, you can see clearly these wind vanes. Okay, so these are the wind power plants. So this is the wind vane. So the axis of the wind vane is connected to the generator. Generator is located somewhere here and electricity is generated. Okay, children, we'll move on to the next. For extra knowledge part, we'll go through this one. Mr. D.J. Vimala Surendra was the first to find that it was possible to generate hydropower in Sri Lanka, right? So this person who found that we can generate hydropower in Sri Lanka, because actually we have a lot of water bodies in Sri Lanka, right? A lot of tanks, rivers. So this person identified that it was possible to generate hydropower in Sri Lanka, right? One of the hydropower stations in Sri Lanka was named by his name. Okay, children, we'll move on to the next now. Now we are going to make a simple cell. So far we learned different methods of generating electricity. I told you basically there are 3 methods of generating electricity, and now we learn how dynamos can be used to generate electricity. Now from here we are going to learn how can we use chemical reactions to generate electricity. Okay, children? So we are going to make a simple cell. So what are the things we need to make a simple cell? We need a copper sheet, a zinc sheet, dilute sulfuric acid, and we need connective wire, copper wire, and we need a beaker and a small bulb. Okay, we'll write this one. Copper sheet, zinc sheet, copper sheet is bronze color, zinc sheet is silver color, dilute sulfuric acid, connective wire, need a beaker and a bulb. Copper sheet, zinc sheet, dilute sulfuric acid, connective wire, beaker, bulb. Okay, let's see how to do this one. Look at the method. Now here we have a labeled diagram. We have to prepare the setup like this, okay? Prepare the setup as shown in the figure. You all can see this is the copper sheet, this is the zinc sheet. You have to connect connective wires to these copper and zinc sheets, and the other ends of these 2 wires you have to connect to a bulb. Okay? What can you see happening immediately after fixing the bulb to the circuit? Record your observations. Remember, children, when I'm explaining this activity in the lab, you have to observe very carefully, because whatever the observations you can see, it will last only for a very short period of time. Okay, children? Therefore, when I'm explaining the experiment in the lab, observe very carefully what happens. Let's do the activity in the lab now. Right, children. We are going to make a simple cell now. Do you remember I explained you all how to make a simple cell? So look at this one. This is dilute sulfuric acid. Okay, children, it is a colorless acid. This is dilute sulfuric acid. And we need a copper plate and a zinc sheet to make this simple cell along with this dilute sulfuric acid. So look at this one. So when we immerse this copper sheet and zinc sheet, they should not contact with each other. Therefore, you all can see this copper plate and zinc sheet. Now this is the copper plate, the brown color one, and this is the zinc sheet, the silver color sheet. So in order to avoid them contacting with each other, these 2 are fixed on the either side of this wooden strip. You all can observe it very clearly. And you all can see 2 wires are connected to each of these sheets. This wire to the copper sheet and this other wire to the zinc sheet, and the other 2 ends of the wires connected to a bulb. Okay, children? So what do we have to do now? In order to light this bulb up, we have to immerse these two sheets in this sulfuric acid, dilute sulfuric acid. But remember children, the observations will be there for a very short period of time. Therefore, observe this very carefully. Can you all see? The bulb lights up, but it is very dim. If you observe carefully, you will be able to see that. At the same time, if you observe inside the vessel, you will see air bubbles come out. And look at the bulb. It lights with, the brightness is very low. Right. Now it doesn't light up anymore. Right children, it goes off. At the same time, when you observe the sheets, you all can see a lot of air bubbles come out of this setup. And the bulb does not light up anymore. Right. Children, we cannot obtain a continuous flow of electric current using this simple cell. Right children, this is a major weakness of this cell. So how does this cell generate electricity? Now I told you this is dilute sulfuric acid and there are two metals, copper sheet and zinc sheet. So when we immerse this copper sheet and zinc sheet in this liquid, in this acid, a chemical reaction takes place. Because of the chemical reaction, electricity is generated. Right children? So in this cell, this is a type of chemical cell or electric cell. So their electricity is generated by chemical reactions. But at the same time, these reactions will not take place for a long period of time. Therefore, bulb goes off very soon. This is a major weakness of this cell. Right children? So you observed what happened. The bulb lights up but only for a short period of time. You observed it very clearly, right? So what did we do again? We connected the two sheets to the bulb like this and we inserted the copper and zinc sheets to this dilute sulfuric acid. So the bulb lights up but only for a short period of time. Soon after about a few seconds it goes off, right? So this is actually a simple cell. This setup is known as the simple cell, but it has many weaknesses. Okay, the main weakness is that you cannot obtain a continuous flow of electricity. The other thing you observed was when I immerse these two sheets in dilute sulfuric acid, what else did you observe children? The gas bubbles form, right? So the gas bubbles form, gather around this copper sheet and because of that, flow of electricity gets disturbed. Therefore, after a little while the bulb goes off because the electricity does not flow through the circuit. So in that case, you have to take out these two sheets, clean them up very well and insert again. Then for another short period of time, you can see the observations. Right children? So this setup is known as simple cell, but there are many weaknesses of that one. We are going to discuss about the weaknesses as well. Okay, right. What is the observation? The bulb lights up or bulb illuminates. The bulb illuminates. After a short period of time, it goes off. It goes off, right? The bulb illuminates. That's the first observation. After a short period of time, it goes off. What is the second observation? Gas bubbles form. Gas bubbles form. That is the second observation. What is the conclusion? You all know that the bulb lights up only when electricity flows through the circuit. Therefore, it's very clear an electric current flows through the circuit through this setup. Right? An electric current flows through this setup. It's very clear now. Okay? Let's write. The bulb lights up when an electric current flows through it. Therefore, the above setup generates electricity. Okay? The bulb lights up when an electric current flows through it. Therefore, the above setup generates electricity. How does it generate electricity, children? Now, you all can see copper sheet, zinc sheet, sulfuric acid. Copper and zinc sheets are metals. Sulfuric acid also present. They all are chemical substances. Okay, so when we immerse these two sheets in dilute sulfuric acids, they react with the acid and chemical reactions take place. Because of the chemical reactions, the bulb lights up. Right, electricity generates and the bulb lights up. When we take out the zinc and copper sheets, when the zinc and copper sheets are outside, can we see the bulb lights up? No. Only when we immerse them in the acid, the bulb lights up, which means the bulb lights up because electricity flows through that bulb. Okay? So, which means when we immerse these two sheets in the acid, electricity generates. This actually happens because of the chemical reactions take place here. Right, children? So, this is a good example that we can show because of chemical reactions, electricity is generated. Okay, so this setup is known as the simple cell. Right? Okay. We'll move to the next. Discuss the weaknesses of the simple cell. So, I explained the first weakness. You cannot obtain a continuous flow of electric current. Because of formation of gas bubbles, we cannot observe a continuous flow of electric current. That is a main weakness, right? Another weakness is, as it contains a liquid, it is not that portable. You cannot take it from one place to another place easily because it contains a liquid. Right, children? What are the other disadvantages or weaknesses of this cell? Now, when you immerse, now this is something you cannot observe right away when you are doing the experiment. But when we immerse the zinc sheet and copper sheet, what happens? The zinc sheet starts to dissolve rapidly because of the acid present. Right? The zinc sheet rapidly dissolves when it is immersed in the acid. Right, children? That is another one. And another weakness of this cell is only a little amount of electricity can be obtained. When you compare it with the other cells and batteries, simple cell generates only a very less amount of electricity. Right? Less voltage. We call this less voltage. Right? Very less amount of electric current is generated in this setup. Right? We'll write these things. Discuss the weaknesses of the simple cell. We'll write. Number 1. A continuous flow of electricity cannot be obtained. Cannot be obtained. Number 2. When immersed in the acid, the zinc sheet dissolves rapidly. Number 3. Difficult to carry from one place to another place. As it contains a liquid. The amount of electricity generated is less than the other cells. Right, children? A continuous flow of electricity cannot be obtained. When immersed in the acid, the zinc sheet dissolves rapidly. Difficult to carry from one place to another place as it contains a liquid. The amount of electricity generated is less than the other cells. So these are the weaknesses of the simple cell. Because of these reasons, we don't use simple cells in day-to-day activities anymore, right? So because this is a type of wet cell. Wet cells means that contains a liquid. Because of this one, we cannot carry these type of cells from one place to another place easily, right? So nowadays we use dry cells. Okay, the cells that are in dry forms basically we use. Okay, let's move to the next one now. Right, children. Now we are going to learn about chemical cells. Now, do you remember I told you electricity can be generated using chemical reactions? That is done by chemical cells. Now, we already learned about the simple cell, that is also type of a chemical cell, right? Okay, so chemical cells. There are two types of chemical cells. What are the two types? The two types are known as primary cells and secondary cells. Primary cells and secondary cells. Right. So primary cells, now as I told you all these types of primary or secondary cells, they all contain chemical substances. Okay, children? So these chemical substances in primary cells, all these chemical substances during reactions when they generate electricity, what happens? They get sometimes at one point they will finish, so that after they finish, primary cells cannot be recharged, right? We have to throw these primary cells away. But what about the secondary cells? Secondary cells can be recharged. Okay, secondary cells can be recharged and we can use them again and again. This is the main difference between primary and secondary cells. Primary cells cannot be recharged. Secondary cells can be recharged. Okay? Right. Primary cells. Chemicals in these cells are exhausted in use, and after a certain period of time, they become inactive. Right? These types of cells cannot be recharged. When they become inactive, we cannot recharge them and reuse them. Okay, what are the examples? Look at these type of cells. There are day-to-day life we use torch batteries, pen torch batteries, like these are. So pen torch batteries and torch batteries all come in under dry cells, right? So what are the other examples for primary cells, children? Look, can you see here button cells present? Button cells contain in sometimes in wristwatches and sometimes in some toys, okay, and sometimes in different other instruments like hearing aids also, these type of button cells present, okay, children. And sometimes in some camera batteries also cannot be recharged, okay, children. We'll write some examples. Dry cells, watch batteries or wristwatch batteries, some camera batteries, right. So when it comes to dry cells, there are different types of dry cells, children. Based on the chemical substance present, there are different types of dry cells present. Okay, now we'll move on to the next, the secondary cells. Chemicals of these cells too get exhausted and become inactive after a certain period of time. They can be recharged by applied electricity to them, right? By passing an electric current through these type of cells, they can be recharged, okay? So in order to recharge them, we have to pass an electric current through these type of batteries and cells, right? So we can use them for a longer period. What are the examples? Vehicle batteries. So vehicle batteries are known as lead acid accumulator because it has lead plates. Lead is a type of metal, right? Lead plates and sulfuric acid, dilute sulfuric acid. Okay? And look at these things, mobile phone batteries and torch batteries. Some of the torch batteries, you all know that some torch batteries you can recharge and reuse, okay? And mobile phone batteries you can recharge, okay? So when you consider these different types of batteries, it's very clear. If you observe even at home, you can check whether what are the different types of batteries you use, and now you can categorize them into primary and secondary cells very easily, okay? Right. So for your extra knowledge, volts, capital V is the symbol, is the unit used to measure electricity. The domestic current is about 230 volts and the voltage of a dry cell is 1.5 volts, right? Do you remember I explained you all about the simple cell? Simple cell voltage is lower than this, about 1.1 volts. Okay, children? So different cells have different voltages. Sometimes if we use powerful chemical substances, based on the chemical substances we use to produce them, the voltage of the cells also different. Okay, children? So this is for your extra knowledge. So however, you have to understand that all the chemical cells generate electricity using chemical reactions. Okay? Right. Look at this one, solar cells. So far you learned there are three main methods of generating electricity. You already learned two methods, right? Using dynamos we can generate electricity and using chemical cells we can generate electricity. When we use dynamos, because of the movement of a magnet, electricity is generated, and when we use chemical cells, because of chemical reactions, electricity is generated. Now we are going to learn about solar cells. Even before I explained you all, solar cells generate electricity because of sunlight, okay? When sunlight falls on solar cells, electricity is generated. Large solar panels are made out of a collection of small solar cells, right? So when you consider these solar cells, one solar cell is a small unit. It can generate only a very little amount of electricity. So in order to increase the efficiency, a large number of solar cells combined together and a large solar panel like this made. Okay, so when sunlight falls onto a solar panel like this, electricity, more amount of electric current can be generated, right? In some areas, a large number of these type of solar panels are fixed, and these are known as solar farms. Now we are going to watch a video related to this one. Right, children. So you watched the solar farm. You watched the video on the solar farm. I hope it's very clear now. Now actually what happens when solar cells generate electricity, solar energy is converted to electrical energy. Solar energy is directly converted to electrical energy. Okay? So which means without solar energy, this type of setup cannot generate electricity. So now we are going to do a simple experiment to identify that solar energy is necessary to generate electricity in solar panels. Right, children. Now we are going to study the function of a solar panel. Now, solar panels can be used to generate electricity. When sunlight falls onto the solar panels, it can generate electricity. Right, children? So, you all can see, now this is a solar panel. You all can see sunlight falls onto the solar panel. Okay? Now, the terminals of the solar panels are connected with this connective wire. And you can see, I have connected it to a bulb. Now I'm going to connect this other terminal also to this bulb and observe what happens. You all can see the bulb illuminates or the bulb lights up. Right, children? So what happens when sunlight falls onto this solar panel? It can generate electricity. So when we connect this wire to the bulb, it lights up because the electricity flows through the bulb. Now what I am going to do is, I am going to cover this solar panel. Okay, children, observe what happens. So I covered the solar panel with the cardboard. Now sunlight does not fall onto the solar panel. Now let's see. The bulb does not illuminate, children. So only when sunlight falls onto the solar panel, it illuminates. So it lights up. Okay, children? So remember, children, solar panels can generate electricity only in the presence of sunlight. So you observed how electricity is generated using a solar panel. Okay, so without solar energy, without sunlight, we cannot generate electricity using the solar panels. Only if sunlight is present, solar panels and solar cells can generate electricity. So using solar panels and solar cells is considered to be more eco-friendly method of generating electricity. Right, children? So most of the time when we use chemical cells, we have to use different chemical substances, right? So some of these substances are harmful for the environment, and when we use the dynamos to generate electricity, we have to use different methods to rotate the turbines. So sometimes we have to burn fossil fuels as well. So you all know now, burning fossil fuels will add different harmful substances to the environment. So when we compare the three main methods of generating electricity, this is the most eco-friendly method. But at the same time, the initial cost of installing these solar panels is very high. But after installing them, we can produce electricity free of charge. Okay, because we are using a natural resource. Okay, children, we'll move on to the next. For your attention, the improper disposal of lead acid accumulators and other rechargeable cells is harmful to the environment. It's very important to recycle them and dispose them correctly. Now, do you remember even earlier under solar panels, I told you all, these type of cells, different types of cells, chemical cells, generate electricity using chemical reactions. But at the same time, after using them, right, when you can't use them anymore, you have to dispose them carefully, right? Because some of these chemical cells contain really harmful substances. Now look at this one, lead acid accumulator. It has a metal called lead. Lead is a very harmful substance. Okay, children, when you dispose it carelessly, what will happen? These substances will get added to water bodies, and when we drink that water, when we consume that water, what will happen? We will face different problems like many diseases as well. Okay, children, therefore you have to dispose them, you have to recycle them, and you have to dispose them very carefully. Right. So we have completed this chapter as well. Do you remember what we learned so far? So we learned different methods of generating electricity, right? We learned that we can generate electricity in 3 main methods: using dynamos, using chemical cells, and using solar cells. So we did a lot of experiments as well. Now we are going to move to the next chapter.